Hello, guys. Yeah, so today we are going to be looking at how to differentiate trigonometric functions. You see, so that will be the goal of this lesson to learn the rules that can be used to apply it when you are dealing with trigonometric functions. So I'm not going to remind people about the identities that relate different trigonometric functions together. So you can do that as homework. Here, we're just going to apply, or we just assume that everyone is familiar with all the identities that you associated with most of the trigonometric ratios that you deal with. And here now, we're going to just learn how to find derivatives of trigonometric functions. So, in order to deal with the differentiation of trigonometric functions, there are certain things that we have to know. That is certain results. You see. So the results that you have to know are the following. So first one, you have to know that the derivative of sine x is just equal to cos x. These can be obtained by using first principles. Then also the derivative of cos x from first principles can be obtained to be minus sine of x. You see. So these results that we have here, if you want to know where we get them from, you can know that these are obtained from first principles. So every time you should just be aware that when you differentiate a sine, you get a cos, and you differentiate a cos, you get a negative sign. But now what you should know is that in general, we have that. So if we now look at a much more general procedure, then we have the following rules in general. So the derivative of sine of some function f of x is actually equal to f prime of x and cos of f of x. And then also the derivative of cos of some function f of x is equal to negative f prime of x sine of f of x, like that. So these are the results that I think they are the ones that are worth memorizing because they've now been generalized to work for any argument that is given to either the sine function or the cosine function. So these last two results are the ones that carry the whole message as to how exactly does one differentiate any trigonometric functions, you see. So to give a demonstration as to how all this work, let's look at the following examples. So if y is equals to sine of 3x plus 2, find dy dx. So how can we answer that one? So the answer to this one is found as follows. So if you want to find dy dx, this is how you proceed. So first thing, every time when you're differentiating any trigonometric function, you start by differentiating the argument. So when you differentiate the argument, in this case, you get 3 and you pull it out. Then after pulling out the 3, you then move on to the trig function itself, and then ask yourself, what is the derivative of sine? We know that is cos, so this is just going to be 3 cos x plus 2. Then another example again, you may be asked to say if y is equals to cos of 5x cubed plus 3x minus 1, find dy dx. How does this go? So the answer to this, it goes as follows. So if you have that, then dy dx goes as follows. So first thing, you differentiate the argument, and you see that you get 15x squared, then plus 3 Then you close this. Then after that, you differentiate the function cos, which becomes negative sine. So we get negative sine of 5x squared plus 3x minus 1. So this is how you differentiate trigonometric functions. It's simple like that. It's simple like that. But these are not the only trigonometric functions that we know we have in maths. So how do we deal with some other functions that we have, like the function term? How can we integrate the function term that we know exist? You see, so let's suppose you're given the function f of x, which is equal to tan of x. Then they ask you to find f prime of x. How will you go about that? So how we proceed here is as follows. First thing, we should recall that actually f of x is just defined as sine of x over cos of x. So we see that this is actually a product of the form sine x, then cos x raised to power negative 1. So we have to recognize that this guy is that. So now the next thing that we have to do now, we have to start differentiating. So what is f prime of x? So already we have learned how to deal with products. That every time when we want to deal with a product, you first differentiate one of the functions, keeping the others at rest. So if I differentiate sine x, keeping the other at rest, I get cos x over cos x. Then now plus, I keep this one at rest, which means I keep sine x at rest now. And then I differentiate cos x to the power negative 1. So I know that any power, a function raised to a power, first I bring down the power, that will make the sign there negative. Then I differentiate the interior. So when I differentiate the interior, I get a sign, a negative sign, sorry, and I take it out. So that negative sign that is going to come out is going to multiply this one, and I'm going to get plus sine squared x. Then I bring in the function cos x to the power reduced by 1. So which means I have to plug in next to this function cos x to the power negative 2. But this is just the same as saying over cos x squared. So which means I just have 1 plus tan squared x. And from identities, we know that this is just the same as saying sec squared x. So which means the derivative of tan x is just sec squared x, like that. You see? So those are the things that you know. So sometimes knowing this result, they can then ask you questions. To say another example is if y is equals to tan of 3x to 5 minus 1, find dy dx. So to find dy dx, this is simple. Already we know that the derivative of tan is sec squared, but now what we're going to do is we're going to apply the same procedures as the sine function. So first you start by argument, differentiate the argument. What do we get? We get 15x to 4. Then now you differentiate tan, which is going to give you sec squared 3x5 minus 1, like that. So that's the derivative of tan. What about other functions like sec? So they can say if y is equals to sec x, find dy dx. So how will we get that? So this is how we proceed now. So we're given y is sec x, but by definition we know that sec is just as saying 1 over cos x, which is just the same thing as saying cos x, or raised to the power negative 1. So therefore to find dy dx, this is how we proceed. First I bring down the power, negative 1. Then I differentiate the interior, I get negative sine x. Then I bring cos x, but with the power reduced by 1, which gives me that. And we see that this gives us sine x over cos squared x, which is just the same thing as saying 1 over cos x times sine x over cos x. Then we know 1 over cos is just the sec, so we have sec x. Sine over cos is tan x. So we can see now that the derivative of sec x is that. So that's it. So what I'm trying to demonstrate to you here is not only to how to differentiate trigonometric functions, but what I want to show you is that just from two results, knowing two results, what the derivative of sine and cos are, you can know how to differentiate any other trigonometric function, either by treating them as products or quotients. So I don't need to now tell you the results of all trig functions. So when you need them in exams, you can derive them. Then now you can go on. Because now what they will do in an exam is that they will then ask you the following problem. They will say if gx is equals to 4 sec 5x to minus 3 plus 4x to the power 6, find g prime x. That's what they will do now. So how would you proceed in a case like this one? So in a case like this one, I want to find g prime x. So same thing, I'm trying to differentiate a sec, but the argument is complicated, so I differentiate the argument first. So the 4, I keep it there, then I differentiate there. So I get minus 15x to minus 4, then plus 24x to 5. But since I'm differentiating sec, I know that I get sec of 5x minus 3 plus 4x 6, then turn of the same argument again, 5x minus 3 plus 4x 6. So this is how one gets to differentiate trigonometric functions. So anytime if you're asked to find trigonometric functions, that's how you go about them. And that's all. So yeah, let's end it here today. So see you